Okay, we're in Chapter 22, Quiz C, Comparing Two Proportions. Let's take a look at our prompt. Researchers conduct a study to test a potential side effect of a new allergy medication. A random sample of 160 subjects with allergies was selected for the study. The new improved brand I medication was randomly assigned to 80 subjects, and the current brand C medication was randomly assigned to the other 80 subjects. 14 of the 80 patients with brand I reported drowsiness, and 22 of the 80 patients with brand C reported drowsiness. Compute a 95% confidence interval for the difference in proportions of subjects reporting drowsiness. Show all steps. Well, first we have to check our conditions. First, the randomization condition. Okay, so the randomization condition. The treatments were randomly assigned, as it said above. The 10% condition. We know that 160 people are less than 10% of the total people with allergies. We have a new condition because we are comparing two proportions, and that condition is the independent samples condition. This means that the two groups are independent of each other, and we know this because the treatments were assigned at random. And then finally, we have to check our success-failure condition. Excuse me. And that information was given above in the paragraph. We know that for brand C, 22 were drowsy, and that is, I think, considered a success, and 58 were not. And for brand I, 14 were drowsy, and 66 were not. So therefore, the observed successes and failures in both groups is larger than 10, so all of our conditions have been met. So what do we know? Well, we know that the sample size for brand I is 80, and we also know the sample size for brand C is 80. We need to calculate p hat of brand I, and we would calculate p hat of brand I, let's see, 14 by 80, okay? And then we'd calculate p hat for brand C, which would be 22 divided by 80. So here's the information we get from that, okay? Our sample space for brand I is 80. Our p hat for brand I is 0.175, and we got that by 14 divided by 80. Our sample size for brand C was 80, and our p hat for brand C is 0.275, which we got by dividing 22 from 80. And again, that information was here in the diagram. Okay, excellent. Now we need to estimate the standard deviation of p hat of brand C minus p hat of brand I. And we know if we're using an estimate, then it's actually, we call it the standard error. Okay, and I'd like to give you the formula for standard error when we are comparing two proportions. Okay, and here is the formula for standard error. And if you look in your Chapter 22 notes folder, you'll see this formula. Okay, and as we learned in Chapter 16, I think it was, in using the Pythagorean theorem of statistics, we know that the variance always adds, and the standard deviation is the square root of the variance. So here is the formula for standard error of two proportions. Okay, so we just plug it in, plug it in. So we expect to have 0.275 times 0.725, which is 1 minus 0.275, over 80, plus 0.175 times 0.825 over 80. And that's what you'll see here. Okay, I think I decided not to write as much as possible because the writing looks like scribble. So here we get our standard error as 0.066. Now we know when calculating a confidence interval, we need our estimate plus or minus our margin of error. And part of that margin of error formula is the standard error, which we've just calculated. We now have a standard error of 0.066. Now we need to calculate our margin of error, and our margin of error is our critical value, which we get from the 95% confidence interval. We know our critical value, our z-value for a 95% confidence interval is 1.96. Okay, so to calculate the margin of error, we're going to say 1.96 times our standard error of 0.066, and we are going to come up with a value of 1.28. So now we have our margin of error, and we're looking for our estimate, and we call that the observed difference in sample proportions. And the observed difference in sample proportions is just 0.275, subtract 0.175, and it doesn't really matter which direction we subtract, but for convenience we're going to choose the direction with a positive difference. It just makes our lives easier. Okay? So here we get our observed difference is 0.275 minus 0.175, which is 0.10. That would be considered our estimate. Okay, so our confidence interval is given by the expression estimate plus or minus margin of error. Here you see that right there. Or our confidence interval is negative 2.8% to 22.8%. And I'm sorry, I said again. What does this mean in context of the problem? Well, it means that we are 95% confident that the difference between the population proportions of patients, say that 3 times fast, population proportion of patients that reported drowsiness for brand C and brand I is between negative 2.8% and 22.8%. And again, that is written right here. We are 95% confident that the difference between the population proportions of patients that reported drowsiness for brand C and brand I is between negative 2.8% and 22.8%. That leads me to the next question, which is question 2. And question 2 says, does the interval in question 1 provide evidence that the side effect of drowsiness is different with the new medication? Well, let's take a look at this interval. What does a negative mean in context of this problem? Well, 0% means there's no difference. So I think what we're looking for in question 2 is we're trying to explain that there's no difference. But we can't say it that emphatically. What would we say in statistics? We'd say there is not sufficient evidence because 0 is contained in our confidence interval. And that means there may not be any difference in the proportion of drowsiness reported between brand I and brand C. You know, we like to be politically correct in statistics. Again, there's not sufficient evidence because 0 is contained in the confidence interval. There may be no difference in the proportion of drowsiness reported between the 2 brands. Okay, stay tuned for video number 2, chapter 22.